So this is the final session. Um, so why do we want to make computed variables? Why do we want to compute variables? Um, the data you collect is not always ready-made for analysis. You need to add some things. Let me confirm something. Sorry. Okay. So you want to derive variables from the variables you already have, just like an instance of what is shared. You have your age, and then you want to group it into this age to this age to that age, and so on and so forth. And in some instances, you want to summarize questions. You want to summarize some questions. So let's say you have a section of questions that is assessing knowledge, and then perhaps the answers to those questions are yes, no. And then you want to group, you want to get the knowledge score, like for each person, how much do they know. So let's say the correct answer for everything is yes, the wrong answer is no. So you want to just assign, it's like you are marking the script, and then assign the knowledge score to them. So you have 10 questions. Anyone that scores all 10 has 10 over 10. Anyone that scores maybe 7 of the 5 correct, of the 10 correctly, has 7 over 10. So you want to do things like that. You want to create new categories, just like was demonstrated. You have age, say from 15 to 35, and then you just go, okay, from 15 to 20 is group 1, from 21 to 25 is group 2, 26 to 30 group 3, and so on and so forth, like that. You want to maybe standardize measures, or you want to just calculate another value from what you already have. So in a case where you have weight and height, maybe you want to check nutritional status or something, and then you have the weight and height of the participant. So you can just compute BMI, check um, to give you an idea of the nutritional status in your sample. And then sometimes you want to have some specific analysis. So you want to regroup into to get some specific analysis. So if you have like I was explaining the other time, if you have so many groups, and then you don't want those many groups in your chi-square analysis, because you will not have enough value counts in each group to give you reasonable results. So you want to collapse those groups. So you can just, instead of having low, intermediate, moderate, high, you can just crash everything to low and high. You have just two groups. That's easier to work with, and you have more reasonable results. So we are going to use this same questionnaire to do a demo. So when you are doing this, you should have your questionnaire by your side, and you are looking at it. It's going to inform what you want to do. So ideally, your questionnaire should be grouped according to objectives. That makes life much easier. So I'm going to split this screen again. I'm going to open my SPSS here. So the questionnaire we were coding the other time, this is actually the same questionnaire. It has been filled completely, and then the encoding has been completed here. All the questions are here, and then it has been filled. It has been entered. We have 125 data points for this pretty small data set. So we are again, we will not touch everything, but we'll just do some things to show us the general um, example of what it looks like. So you can use this, like I said, you can use it to clean data. You can use it to clean data. So if you look at this is my serial number. Let me reorder this, sort ascending. So if you look at this point, you are going to see this empty, this empty. So one reason why we want to compute new variables is to clean data. Can use it to clean data as well. So this is empty, this is empty. I will just do this sort ascending, and it's going to show me how many empty values I have. So sorry, right click on this title, right click on this title, and then sort ascending. So it's going to, everything that is empty will come up, anything that has something in it will go down, so you can easily see what is missing from there. So if I check this view, and I turn it to value labels. Okay, it's not showing it. But if you see behind, you will see that this ones actually have 99, so their system missing. So, but I'll just proceed. What we want to do now is that I want to cleaning this in the sense that I don't want any missing value. In fact, before you start doing computations, you want to ensure you don't have any missing value, and we have discussed how you can handle missing value. So I'll go to transform. Okay, replace missing values is what I'm looking for. So I want to replace missing values in age. So it's labels it as Q1 age 1. I can leave it like that. So how I want to recode is to replace those missing values with the mean age there. Okay, and then I can say, okay, you could use the mean of everything, but I like to be a little more nuanced. I will just use mean of nearby points. So, and I'm going to typically use maybe something like 4 or 5. So that means it's going to look at the 5 variables that are surrounding that point where there's a missing value. It's going to take the average and then use that average to fill in that missing value. If you like, you could just use series mean, so that you just take one mean of the all the ages and then fill it fill it in that way. So yeah, that's what I want to do. So I'm going to press okay, okay. So you see this output, you want to save it. Very importantly, you want to save it. So I'm going to save it because it's a summary of everything. It's a summary of everything you are doing. It's a summary of all the processing you are doing on your data. So you want to save it. So you can see here that and then I have done this filling of missing data. It summarizes everything you are doing in case you need to trace your steps. So I'm going to scroll to the end. You will find that it has already placed it at the end, but it's having decimals. I don't want decimals. I don't want decimals. So I'm just going to remove this. So it's going to just give me the nearest value. So I want it to be close to the other one. I will just click here and drag it up so that it's beside the same edge. So when I come back here, it's already beside it. So all those missing have been filled with the value. These were the missing data, and now it has 23. So the mean age generally seems to be 23. So I'm going to reorder this back, sort ascending. So that is, we have derived a new variable and use that to clean our age variable. So that is one use case. I'm going to proceed. Okay, so I'm going to leave this ones. The next one we want to check is level of study. So you have 200 level, 300 level, 400 level, 500, 600 level. So this might be, you can do your univariate analysis and then get how many descriptive statistics for all the levels. But if you want to do maybe your bivariate chi-square and stuff, you might want to collapse this. So I want to collapse this into, okay, I was also supposed to group them into equal classes, but Chief Razak has taken care of that, so we don't need to go over that again, do we? Yeah. So what we can do here is that we can divide this into preclinicals and clinicals. So this is what I'm going to do. I'm going to come to transform, recode into different variables. If you are going to recode into the same variables, then you have to be very sure what you are doing, because once you have done it, it's done. You might, if there's an error, you might have to restart, as in restart from the beginning. So it's safer to use, except you are very sure, it's safer to just recode into different variables. So what I want to do now, this is the importance of giving descriptive labels to your data. I don't need to start checking which question is this. This is level of study. I know it's level of study. So I'm going to click it, move it here, and then the new variable I want to be, I'll just call it Q4 for consistency. Q4 level, maybe class or group or whatever you want to call it. I will now say classes in preclinicals and clinicals. Change. Then it's going to ask me to input my old and new values. Now remember that when we were doing that encoding, 2 was 200 level, 3 was 300 level, and so on. So what I want to do now is I want to take, okay, I can't use a range here. So this is the old value, this is the new value. The one that was currently 2, Now that means 200 and 300 level, I want them to be preclinical. 4, 5, 6, I want them to be clinical. So we can take that as 1 and 2. So that means the ones that were 2 and 3, I want them to be 1. The ones that were 4, 5, 6, I want them to be 2. So now this is another disadvantage because we coded this as strings. I cannot use the range. I would have just said from 2 to 3. But because we coded as strings, if I coded as numbers, because I've just done that. But we'll proceed anyways. Sorry, that should be 1. I'm going to add. 3 is also going to be 1. Add. 4 is now going to be 2. Add. 5 is also going to be 2. I'll add. And 6 is also going to be 2. And then I'll add that. And then I'm going to continue. So you can see some other options here. System missing. If they are missing values, you can give them another variable. If you want to explicitly say these ones are missing, you can do that. If there are other values, let's say you now have other groups like MSc, postgraduate, and those ones, you just want to put them into a group called order. So I'll just take any other thing that is not in this 2, 3, 4, 5, 6, put them as order, and then I can call that 3 if I want to, but we don't have that here. Continue. Okay. So it has again written what I have done here. Make sure that is always saved. And then if you scroll, it usually adds those new variables to the very end. So you can see it here, Q4 level class. I don't want it to have decimals. I don't want those decimals. I'm going to turn this to 0. And then I'm going to now have to do this coding of the labels, of the value labels. So 1 now is preclinicals and 2 is clinicals. I'm going to drag it again. This is optional, but it helps you to keep sane if you do that. So I'll drag this to stay beside the other level. So if we check it in the data view now, I'm going to go back here. 400 level is clinicals as expected, 400 clinicals, 600 clinicals, 500 clinicals, 300 level preclinicals, 200 level preclinicals. That is what we expect. So that is going fine. So let me see which other one is important for us to look at. Okay, sorry. From where? From the beginning of this recording. Okay, so this is what transform, recode into different variables. Then the one we did before is still there, so I'll just continue with it. I won't clear it. So you select the one you want to record, move it here. Then here, the output variable, the name that you want it to have, and then the label. Remember, the name is the code one, and then the label is the explicit, very much explanatory one. So you just as you want it to be. Then you click change. I don't need to change anything here. And then I will now go to old, and we are recording, so we are converting it from one format to another. So go to old and new values. So remember that when we coded this data initially, we coded 200 level as 2, 300 level as 3, 400 level as. But now we don't want all of those classes. We want just 2. We want just preclinicals and clinicals. So that means 200, 200 should now be interpreted as one thing, preclinicals. 4, 5, 600 as one thing, clinicals. So I'm going to say this is the old value. This is the new value. The old value was 2. For 200 level, it was 2. So I'm going to type here 2. And then the new value that I want it to have now, I have foreseen that I want my preclinicals to be 1 and clinicals to be 2. So the old value was 2. Now I want it to be 1. So I'll put the 1 there and add it. It's already here. The same thing, 3 is going to 1. Now 4, 5, 6 are mapping to the second class, clinicals. So I'm going to have 4 will now be 2, 5, 2. And then when I'm done with that, I'm going to click continue. I won't click continue now because I've already done that. So the next thing I was now saying is that when you do that, when you come to the data view, it's going to be showing as what you just coded 1, 2, 1, 1, 2, 2. But what you want to see is not the 1, 1, 2, 2, 2. So you are now going to just the way we did when we were encoding data. You will now come here and say, okay, I want 1 So we are now labeling it. We are labeling this, the ones and twos. So the one will now be preclinicals. So I'm going to label it as preclinicals, and then two I'll label as clinicals. When I click OK, it's now going to map it automatically. So everything that is one becomes preclinicals, everything that is two becomes clinicals, and that's what we can see here. Is it clearer? I'm going to align this to the left because that is a little confusing. Yeah, that looks better. Okay, so another thing again that we do with this computing is typically when you have a Likert scale, you want to. So we have seen two use cases: cleaning data. Another use case in regrouping data or collapsing categories. Now you want to compute variables. Now each participant is going to have an answer in this place. I feel overwhelmed. I worry about, and so on and so forth and so on and so forth. So we want each participant to have a single score for each of these questions. Sorry, for all the questions. So it is like we are now getting the total stress score. So someone that ticks never here has a score of 1. Let's say the person ticks really here has a score of 2. 1 plus 2 is 3. Picks never here has a score of 3, has a score of 1. Add that is 4. Let's say here he now picks what is here always, that is 5. Add that up. But of course you can't reasonably expect that you will do that for every participant. You have 125 here, sometimes you can have up to 300. So SPSS provides a way to do that. So let's go to it. I have done some cleaning on this data before here so that we will not waste time on that. So this is, yeah. So looking at this, I see everywhere I put stress, I know that it belongs to the Likert scale. So it's, I don't have to go and start tracing which question is coming from where. So I know that this stress up to this stress, up to this stress, not this one, up to this stress are the things I'm dealing with. That's Q13 to Q22. Yeah. Okay. Sorry, Q11 to, is it Q11 or Q10? Oh, I have skipped. So Q10 to Q, um, that's not contract. Okay, somehow this is 13. Oh, I think I might have, it's supposed to be 10. I might have done some adjustment I should not have done. Anyways, what I'm pointing at is that, yeah, it's 13 to 22. So from this point to that point. So what we want to do now is that we want to add all the scores. So for this score, you can see that now is in rows. So from here, this is sometimes that will be a score of 3, 3. Remember, we coded it as numerical. If I coded it as strings, we will not have been able to do this. So this is 3, 3, this is 1, this is often will be 4, and so on and so forth up to that point. So we are going to add that together for this person and then get a score. The same thing for the next person, get a score, for the third person, get a score. So what you do there is transform compute variable. Now there's another way to do this in syntax, but we are not, I don't want to go into syntax. Um, So passive stress, everything that is passive stress is what I'm dealing with. So this can get a little caveman like. The target variable, let me call it passive stress score. Passive, let me use camel stress score. Type and label is going to be numeric sum of passive stress. Okay, so I want to add everything in that place. So it's easy. We have gone to transform compute variable, take this, move it in, plus, now this is why I say it gets a little caveman like. I wish there was a way to put everything at once, but so far I have not seen any reasonable way to do that. Plus this one, or one shortcut is to select everything. I know that all I'm doing is in this passive stress category. Select everything. Oh, I can't even select everything. Um, Sorry, let me confirm this. This is the problem. This was coded as string. In the clean data, I coded it as numerical. So I'm going to just turn it to numeric. That's why I could not do that. Numeric. This is why it's advisable to code as numeric. 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 Okay, let's try that again. Okay, so I'm just going to use the ones that are showing to illustrate so that we don't waste time on that. So I'm just going to move them one by one since it's not allowing to select at once. So I'm just selecting all the variables in that place, and then let me see if it's going to allow that. Okay, so I've done the summing. So let's look at what we have just created. You can see down here now that we have the sum of perceived stress costs. So I'm going to just, you don't have to move it, but I prefer to move it so that everything is together, just to the end of the stress score. So let's look at it. So you can see the sum of the scores. So if you are going to take one as an example, okay, you don't have to do that. So you just, that when you add this plus this, the values that are associated with it is going to give you the sum of 20. This one gives you a sum of 24. This one's a 34, rather. This one gives you a sum of 26. So just that way you have gotten a sum of perceived stress score. So everything here has now been collapsed into one variable. Do we get? Okay, I'll take it again. Let me delete it. Perhaps because I was having those glitches. So I'm going to take it again. Okay, you understand what we are trying to achieve? That much is clear. Okay, sorry. We are trying to calculate a single score for this passive stress for each participant. So look at this. This is the stress score from here to here up to this 23. Now, what we want to do is this. If you look at from 13, sometimes here will be 3, right? So this is okay. Let me switch it to the um, value label so we can see. Yeah, sometimes it's 3. This person, another sometimes. This is 1. This is never. This is 4. That's often. So what we want to do is that for this person now, for this respondent, we want to add everything under this stress score, everything in this table, everything in this table. We want to add this together and get a single score so that we get an overall score for that person's passive stress. That's what we are trying to achieve. So how we do that is, now let me switch this back to value labels. So how we do that is by going to transform compute variable. Okay, and then what I'm now doing is that all those variables that we want to add, I'm moving them. I have looked for a way to move it at once and do that, but I have not found a reasonable way to do that. So okay, there's one way, but let's not go into that now. So what you do is you have to move it one by one. I don't want to return all this so we don't spend time on it. Should I return it? Okay, let me return it. I will just select everything and return it. Okay. So we know that everything we are dealing with is this perceived stress. Somehow these guys have not changed. Okay, okay. So everything we are dealing with is this perceived stress. So I'm going to take the first one. I know I want to add everything there together. I'll take the first one, move it here, plus the second one, move it here, plus the third one, move it here. So we are adding value those values that are associated with them. The fourth, this is the fourth or the fifth. This, 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 this can be quite tedious, and then this. So I have added all of them together. So all I just need to do now is press OK. And then by the time I press OK, it's going to compute it. And of course, you can see it has told us what we did. We computed some of this plus this plus this plus this plus that. So I'm going to go back to my data, and you are going to see you should have taken it back to the end. So look at it here. This is now the result of those additions. So the 3 plus 1 plus 2 plus something for that row, it has added it. For the next row, it has added it, and then it just gives it to us like that. Is it clear now? Okay, thank you. In Yeah, you will see it has sort of given you, it has sort of done the encoding for you in the variable view, but of course you will not see those raw values in the variable view, only the data view. So I prefer to move this close to where I got it from, so that when I'm doing other things I don't start looking for it or get confused. Okay, so that's another use case of it. So another use case of, do I want decimal? Okay, yeah, you can have decimals there. All these right aligned things are looking somehow. So another use case now is um, Dr. Razak showed us visual binning of variables. So another use case of computing visual binning, where you divided age into different categories. So another use case of computing variables is you can also use it to group data into different groups. So a typical example, this perceived stress now, I want to group it into different classes. So we might not, again, in this circle, in this community, you typically not do analysis with raw numerical variable. They prefer you give them chi-square. So we are going to group this into classes. So we are now going to have something like low stress or moderate stress or high stress. So I'm going to, one thing I like to do is now to come here. I'm right clicking on this column, then I'll just come to descriptive. Okay, let me actually go the whole way and do analyze descriptive statistics, frequencies. The one I'm dealing with now is the sum of perceived stress score. So I'll move it here. So it's going to ask me what analysis do I want to do with this. So I'm going to come and say I want the mean, I want the median, I want the mode, I don't need the sum, I want the minimum, I want the maximum, maybe standard deviation and variance, but let's not necessarily, but let's just get it. I can get, okay, let me just get the percentiles. So what I'm trying to get here is that I'm trying to look for the convenient place where I can divide the data. Visual binning is a good way to go about it. That one, everything is clear. You have the minimum, you have the maximum, it even shows you percentages and all that. But this is another way to do it. Mean, median, mode, percentiles. Oh, I'm supposed to. Um, okay, let me just leave the quartiles. Then standard deviation, variance, range, minimum, maximum. So let's just go with this. We are just trying to demonstrate something. Okay, it's processing. Okay, it's done. So this is what we are looking for. The minimum score is 14. The maximum score is 49. And we can see here we have percentiles. Percentile is like when you break it into four different points. You have 28, 32. The 26 percentile is 28, 50th is 32, 75th is 38. So a lot of supervisors advocate that you should, or yeah, they usually advocate that you should use equal class width. So that means if I want to break this into three classes, I want those ranges to be three equal class width. What I mean is this: the minimum is 14, maximum is 49. The difference there is what? That's 35, right? 35. So what's the closest I can get to cutting 35 into 3? That's I can cut it by 12. So I can just decide to say now 14 to 26, 26 to 38, and then 38 to 49 will take the rest. That is one way to do it. But usually I prefer to get a little more nuanced. If I want to cut it into three parts, I can decide to maybe say plus or minus mean the plus or minus standard deviation. So this is the mean, and then I'll add the standard deviation on this side, and then standard deviation on this side. Use that as my cut point. Other times we want to use stattiles like group. You know, when we did this give now, the advantage of that is just that in some instances you will have a lot of the data will be, even if you have 14 as the lowest, you can have um even if 14 is the lowest, it can be that you only have 114, 115, and then you have 30 that are scoring 35, 40 are scoring up to 39. So it's going to be really skewed. So when you do your analysis, you are going to have a lot of screen data. But for the purpose of this demonstration, we are just going to do equal binning. So I'm going to now come here, and we are still going to transform, recode into different variables, and then I'm going to reset this. This was the one we did initially. I don't want it anymore. So the variable we are binning now is this sum of perceived stress. So I'm going to call it sum perceived stress grouped, grouping, or you can call it classifying, whatever, of perceived stress. Click change so it saves, and then old and new values. Now we can use range. Remember, we are using from 14 to 49, and we are using equal class width of 12. So that means the lowest is, we are starting from, sorry, range from the lowest value, which is 14, up to 14 plus 12 will now be 26, up to 26. So I want that to be my first class. I'm going to add it. Then the range from that 26, I'm going to say 27 up to 38, right? That will be my class 2. I know that every other thing remaining belongs to the remaining class. So I can either say from 39 to highest, so I can just say all other values that should belong to my class 3. And then I'm going to click continue and OK. It's processing. Okay, so that's done. Then I'm going to come back here. If we check it again in the variable view, we'll see that it's already present here. The sum of the perceived stress cost. So again, I'm going to just, that was not what I should do. Again, I don't want this labels, sorry. I don't want this decimal rather. And then I want to add labels. And I want, one is now going to be low stress, two will be moderate stress, and three will be maybe severe stress. Let me say high stress. So that means anybody that scores between 12 to 20 to 26, we consider them to be having low stress. Anyone that scores between 27 to 38 is moderate. Anyone that scores from 39 to the highest is a high stress level. So I'm going to move this again to where it's supposed to be so that I'm not looking for it later. Okay. Yeah, so this is it. So you can see that as expected, 23 is low stress, 37 is moderate stress, 48 is high stress, and so on and so forth. Does it make sense? Does it make sense, honestly? It will make sense. You said? Okay, so we'll proceed. So let me see if there's any other thing that we time is mostly out already. So perhaps I'll just say these ones. Ask your question, please. Okay, I'll walk through it again. We understand up to where we did the certain run through it again. I'll run through it again. We have gotten the perceived stress course. Now, what we want to do now is just we don't want these raw values. We are not going to really use them for analysis. So what we want to do is classify them, and typically maybe into three groups. So the initial thing I did was just for us to decide where our cutoff points will be. If you are more convenient using the visual binning, you can go for it. That is perfectly fine. But I'm just demonstrating that you can also use compute variable to get to create new groups from this. So we saw that our lowest value was 14, the highest is 19, and 49, the range is about 35. So if you want to divide into three groups, you know that the closest you can get is to divide into groups of 12, 12, 12 scores. So what we now did was I came here to transform, recode into different variables. Note that compute means that you are bringing some data together and forming a new one. Recode into different variables that you are taking one that you already have and just transforming it into something else. So in this case, this sum of perceived scores, we want to recode it into something else. We want it to look different than it was. So in case you are wondering where do we use compute, where do we use recode? So I drag this into the this numeric variable output, whatever part, the variable I want to work with. And then I know that my first class is from 14 to 26. I can either come here and say range 14 to 26, or I can just say that I want to use this range from the lowest through to a particular value. So the system knows the lowest is 14. So it takes the 14, and all I need to do is just put the higher cutoff point, 26. So it knows that that is 14 to 26. And then the second group is in the middle, that's 27 to 38, and then I assign that to 2, and then any other thing I know that belongs to class 3 automatically, and then I just press all other values belongs to class 3. And then what I did here now was just what we have been doing before. I came to this, where is it? Yeah, so we know we have 1, we have 2, we have 3. So now I'm just labeling them at this point. So class 1, we consider it as low stress, class 2 as moderate stress, class 3 as high stress. Do we get? Okay. So, okay, we have already done something like this with the other age that was demonstrated. So the extra note I'm just making here is that sometimes there are already standardized methods of classifying something. So instead of looking for bin or where should I cut it from, you will know that okay, we have specific scientifically and research pathways of grouping this. So in the case of menarche, for instance, okay, in this one I found one, but the supervisor said no, that they want it to be equal class, so I have to replace it with this. But this is something we all know. Someone that has menstrual cycle less than 2, we know that that one is sacrosanct. So if people have entered the menstrual length cycle, you can just say you want to now regroup it. You can just say anybody that is less than 21 days, we know that this is what they have. Anyone that is between 21 to 35 days, we can say that is normal. Greater than that, we know that that is another class. So this is just to show that sometimes we use what is already established instead of looking for new beans and things like that. Okay, so one final thing we are going to do. Now this one, you want to create a score, but it is not exactly obvious. At this point, we have the Likert scale, and then we can just, we know that okay, this is 1, 2, 3, 4, 5. We add that for all of the questions. But this one now, it is not obvious here. So we want to get, what we want to get is now is that a menstrual age score. We want to get a menstrual health score from this section C that shows menstrual health history and disorders. So we cannot use this to compute a score. We can't use it to compute a score. We can't use this. Uh, so but we can now start from this point and say that okay, this is 1, this is 2, right? If we encode it, this will be 1, this will be 2, this will be 3. Do you experience painful menstruation? Anyone, excuse me, anyone that answers yes scores 1. Anyone that answers no scores, excuse me, 0. Now this is a point where if you had encoded 0 as no as 2 when you were doing your data entry, you want to recode it to be 0, or else it's going to take it as 2 and add it as 2. So you want to pay attention to that. Yes, yes. So let me see. I don't know why this number orders have changed. I probably scattered something I should not have scattered. Okay, yeah, this is, do you experience painful menstruation? So let me check it in the value labels. So you can see no is coded as 2. That will be a problem. So I will have to record that. So in this case, I'm sure of what I'm doing. So I can just transform, I can transform and recode into the same variable. And then what I want to record is, do you experience painful menstruation? So in this case, my 1 is still my 1 because yes is still yes. 1 will remain 1, and then 2 will now become 0. So that's that. It doesn't create a new variable. It just records into the same variable. If you are not sure of what you are doing, please don't do that. It's going to be a problem. So now it's showing 0 because it doesn't know what 0 is. So what you just do in that case is come in here and then just change this and say I want 0 to now mean no. Change. So by the time we go back, we'll find that it is behaving as we want it to. It's behaving as we want it to now. Okay, so where was I? Yeah. So anyone that's experiencing dysmenorrhea, painful menstruation dysmenorrhea will score 1, and this other person will score 0. How would you classify the pain? Mild, of course, should be 1. Moderate is 2. Severe is 3. Do you experience unusually heavy periods? Yes is 1, and so on and so forth. So one thing we want to pay attention to is here is that if somebody says, if somebody answered no to this question and then they still went ahead and picked something here, you know that person, there's a problem with that. Because if you say no, then what are you classifying? So what I will do here, this is just a tip, if you will. So I'll just sort ascending. So anybody that picked no, anybody that, we even have some missing data here. So like we were shown earlier, the majority is yes. So I'm just going to fill this with yes. So anybody that picked no and add something here, I'm just going to come and delete it because they are not supposed to have anything there. You have said no. So that is also another type of data cleaning. It's easy to do these things in this case because our data set is relatively small. If you had like 1,000 or 100,000 variables, of course, you cannot expect that you go through it one by one visually and be changing things around. And then all the ones that answered yes, they have something picked. So that means this is 0 or 1, and then this is also 1, 2, 3, and so on and so forth. So the way we summed for the Likert scale is the same way we can also sum for this. You get? So we just, we can add this and add. Okay, let me see if I can, if we can easily do that. So now we are using compute variable, and we are starting from where, do you experience this? Let me reset this so that it clears everything from there. So I'm starting from, let me start from, do you experience painful menstruation? I'm going to add that. Have you ever, oh, you experienced painful menstruation? Have you, okay. If yes, how would you, so that is the next. Do you experience what's that one? If you over it, it's going to bring out the full thing. Do you experience unusually heavy periods? I'm going to add that. Plus, have you ever missed your menstrual cycle? Add that. Do you ever experience any bleeding between periods? Add that. Have you ever consulted a doctor? Add that. Now, if you specify, we cannot add that because it's string variable. We can't add that, so I'll skip it. Menstrual, whatever, whatever. So I'm just going to keep adding. I know what that means. Oh, okay. Now we have a real constraint. So I'm going to just rush up. Do you feel academic performance is affected? I'm adding that. And then the final one. Okay, so let me see if I can add this just for demonstration and then we'll close up. Menstrual health score. Ah, I have put in something I should not have put in. Let me see if we just work with this. Okay, it's saying I have put in a string variable somewhere, but because of time, I'm not able to cross-check that now. But the point is that when we add all that together, you can get a definite score. Now, one last thing I will just point out is this. You will notice here that according to how these questions are ordered, someone that has a better menstrual health is going to have a lower score because where is it? Where is it? Where is it? Okay, so do you experience painful menstruation? Someone that answers yes, we can say that that is worse. Someone that answers no will score 0. In this case, how would you classify the pain? Someone that has lower pain will have a lower score. Someone that has more severe pain will have a higher score. If you come here also, someone that has unusually heavy periods is going to score a higher score, and someone that doesn't experience to score a lower score. So you realize that by the time you add all this together, the score is actually going to be inverted. It's going to be such that whoever has higher score actually has better menstrual, sorry, whoever has lower score has a better menstrual health, but whoever has a higher score has a worse menstrual health. So that can be a little confusing when you are doing interpretation and other analysis. So what you want to do is just invert it. So by inverting, you just, okay, if you look at all this, what will be the total score? What will be the maximum score? So let's assume when you add all of this together, the maximum score you are going to get is 12. So after I've gotten the score for each participant, I'm now going to say 12 minus that variable. So it's going to invert it. So somebody that scored 1 before will now score 11. Somebody that scores 11 before will now score 1. So that way it follows a more natural, sensible order. And then that is easier to interpret. So I think that demonstrates what we have to demonstrate. And then similarly, we can compute impact costs the same way. Yeah, so that is that. A few additional tips: avoid overwriting. I've mentioned that. Always duplicate your file. If you are okay, I've mentioned this. Recode. Deal with missing values before making any computation, and then document everything. Ensure that this output you are getting here is always saved. So we are going to stop here for today. So, so there we are recording. The recording will be shared. So thank you very much. See you tomorrow. Tomorrow we are doing reporting interpretation, then how to use AI to optimize, and then questions and answers.